This is everything you need to know for pre-calculus, part 5. So we're talking about algebraically testing for symmetry, and so let's start with our first example. So we have x minus y squared equals 1, and I have a rough drawing of the graph here on the right. Okay, so just by looking at it, we can tell that we probably have symmetry with respect to the x-axis. Okay, the x-axis divides that graph or that line into half. It's like a mirror image. Okay, so I'm going to write down symmetric with respect to x-axis. And so what we're going to talk about today is how do we algebraically test or confirm that it is symmetrical with respect to the x-axis. Whenever we're talking about with respect to the x-axis, we should be able to have an xy pair and an x negative y pair on the same graph. So the way that we can test that algebraically is we're going to take our original equation and we're going to replace y with negative y and see if we still end up with the same equation. Okay, so here's what that's going to look like. So we have x minus y squared equals 1. I'm going to write that. So x minus, this time instead of y, it's going to be negative y. So negative y parentheses squared equals 1. Okay, and so now let's simplify our equation. So negative y squared, well, anything squared is just the positive version of that, okay? So we really don't need that negative sign. So it's going to be x minus y squared is equal to 1, okay? And if you notice, that is the same thing we have up here, x minus y squared equals 1. So we end up with the same equation. So that's just a real quick, easy way to test it algebraically. All right, let's do one more example. So this time we have xy, or x times y, is equal to 4. Here's my beautiful drawing of that equation, that function. And so just from looking at it, based on what we talked about in the last video, I'm thinking that this is symmetrical with respect to the origin. So I'm going to write symmetric with respect to origin. Okay, and so remember that whenever we have graphs with symmetry like this, if we have a point xy, we should also have the point negative x, negative y. Okay, so for example, if we have 1, 1 over here, then we should have negative 1, negative 1 over here, which it appears that we do, but we're going to test it algebraically. So the way that we do that, kind of similar to the last one, is instead of having xy equals 4, we're going to replace x and y with negative x and negative y and see if that equation is still the same. So if we do that, we would have negative x times negative y is equal to 4. And so negative x times negative y, well, negative times a negative is a positive, so we really don't need those. So this would be equal to xy is equal to 4, which is the same as what we started with. And so that confirms algebraically that this graph, this equation, is symmetrical with respect to the origin, and that is all you have to do. So I hope this video was helpful. If you want to see more like this, go ahead and follow this account, like this video, and leave a comment. That way my videos show up in your For You page later on. We'll see you next time.